In this lesson, we're going to be talking about linear equations, and we're going to be talking about parallels and perpendiculars, and just if you're given slope or you're given 2 points, how do you create this equation for a line? So there's going to be 2 different methods. We're going to eventually kind of focus on this method, but definitely both of these methods will work throughout every single one of these problems, so it's absolutely up to you. I'll show both on the first problem, but then I'll probably focus more on this one because when you get into some higher up math, this ends up being the method of choice. You'll see it in all the books. So here you'll see it as we go through it. So there's going to be about 4 different problems, and every single one of them is exactly the same, but the only difference is how you find the slope. Either it's given to you, you're going to have to find it between points. They're going to talk about parallel and perpendicular, but otherwise it's really the same process and the same stuff every single time. So the first situation that we have is we're going to be given a slope and a point. The point is almost always given. Very rarely do they give you a situation where you don't have a point. So usually it's some information, but there's almost always a point attached to it. So here's what we got. So first situation is we're going to be given the slope of negative 1/3, and we're going to pass through 6, negative 2. All right, so we're going to have some sort of an equation. We're trying to figure out the equation for it, and it's going to have that slope, and the graph has to pass through this. Well, there's literally only one equation that has that particular slope that passes through that particular point, and we're going to try to find it. So we're going to do both of these 2 different methods. First one is we are going to use y minus y1 equals m times x minus x1. And the problem with this method is you got to remember the formula. So the formula is you need to have a point. That's what this x1 and this y1 represent. So this is the x1, this is the y1, and you need a slope. If you find a slope and a point, then you definitely can use this method. And they give us a slope and a point. So we plug in exactly what we have. So we have a y minus, and so I'll just kind of leave the value. So it's going to be y minus the y value. So y1, so that's a negative 2, and then it's going to be x minus the x value from our point, 6. Then it takes 2 points, or 2 steps that we're going to try to basically eventually turn it into a slope-intercept form. So first thing is, we have a slope. So our slope is negative 1/3. And we want to get rid of parentheses. So we're going to eventually try to create this. So this doesn't have parentheses, so we're going to distribute. So we'll distribute that in, and we'll get a negative 1/3 x. A negative times a negative is going to be a positive. A third of 6 is 2. And then here we can clean it up a little bit, where we're going to subtract the opposite of 2. It's the same thing as adding 2. And the last step is we're going to try to get y by itself. So we'll subtract 2. And so that's going to give us a y equals negative 1/3 x, and then this cancels away, so it actually just looks like that. So we're done. We have our equation, and we'll actually show it on a graph here in a second, that when you graph this, it has the specific slope we're looking for, and it's going to pass through that point. Our second method is going to be y equals mx plus b. We're going to jump right into y equals mx plus b. That's what we're looking for, so let's plug it in. Now the difference is we still have our coordinate and we have a slope. So rather than the x and the y being the x and the y eventually in your equation, we're going to substitute the x and y with the actual coordinate that they give us. But we don't know the y-intercept. The y-intercept would be a 0 something, and they don't give that to us. So we can substitute in the y value with negative 2. We can substitute in the slope with negative 1/3, the x value with 6, and we are looking for the b value. So the red is what we can substitute in. So negative 1/3 of 6 is going to get us a negative 2 plus b. It's going to equal a negative 2, and then we want to take the negative 2 and bring it over because we're trying to get b by itself. And that is going to tell us what our y-intercept is. Well, that becomes 0. So our y-intercept is 0. So our equation is y equals our slope, which was given, negative 1/3 x plus our y-intercept of b, which is 0. So we could put plus 0, or we can just leave it. So it gives us the exact same equation. All right, so if we want to check it, we can do a visual. We can plug the point in and make sure the point works. So for this one, we'll just kind of do a visual for a second. And this one has a y-intercept of 0, has a slope of down 1 over 3, because our equation is negative 1/3 x. And we're checking to see if it passes through 6, negative 2. So if we go down 1 over 3, down 1 over 3, down 1 over 3, up, back 3, up, back 3. And if we connect our dots, I'm looking to see if 6, negative 2 is one of them. So 3, 6, negative 2. Perfect. So it has the exact slope that we need, and it passes through the point. So that's definitely the right equation. So either one of the methods work. Absolutely up to you. Figure out what works for you, what makes more sense. Again, if you're kind of going up to some higher up math, this is definitely the method that gets encouraged. So you might want to just kind of get in the habit of using that. So second one. This one is our slope is going to be undefined. This is going to be kind of a special case. So it's going to have an undefined slope, and we're going to pass through the point negative 5, 3. So kind of a special case. When you have an undefined slope, it's either going to be a vertical or a horizontal. And so I kind of have to make sense of this slope here. Our slope, in order for it to be undefined, means that we have a 0 in the denominator and something in the numerator. So rather than jumping into this, I'm going to kind of create a visual for it. So 2, 3, 4, 5. So I'll plot the point for a second. So here's our negative 5, 3. And I have to have a slope that has rise but no run. And that is going to be a vertical. So an equation for a vertical line is always just x equals. So our answer is going to be x equals, and wherever it passes the x-axis, which is at the negative 5. So that's it. That one's very, very different than this. So if it's an undefined slope or a 0 slope, those are your special cases. They're verticals and horizontals. They don't have the same kinds of method that we use for this. So let's give you another situation. Our second situation is going to be, so the first one was we were given the slope and a point. This time we're going to be given 2 points. All right, so our points are going to be 3, 5, and negative 3, 1. All right, so what I still need every single time to use this is I need a slope and I need a point. I don't have a slope, so I need to find the slope. So on this one, my slope is going to be my change in my y's compared to my change in my x's. And I can pull that information right from the coordinate. So change in my y's are going to go from a 5 to a 1. So we're going to be going down 4. And then our x's are changing from a 3 to a negative 3. So then that's going to be a down 6. And that simplifies to a 2/3. Okay, so we have our slope. We are exactly in the same position we were right here. We have a slope and a point. Now actually we have 2 points. So we can pick whichever one we want. I might select this one because I don't have any negatives in it. Or you can select this one because maybe the numbers you look at them and they're a little bit smaller. It really doesn't matter. So from here, we do our formula. Okay, and so we have y minus a y value. I'm going to take this one. So I have a y minus 5, and that's going to equal our slope, 2/3, and then times x minus our x value of 3. And we'll walk through the math from here. So it takes the same 2 steps every single time. We'll distribute. So y minus 5 equals 2/3 x minus 2/3 of 3 is 2. And then from there, we'll add 5 over. And that's going to get us an answer of 2/3 x plus 3. Now to double check it, I could graph this and make sure both points are on that line. I also could take the second point that I didn't use, plug it in and make sure it adds up to what it's supposed to. So if I plug in a -3, do this math, it's supposed to add up to a +1. And that's how I can check it. All right, we have 2 more problems, and that is the parallel and the perpendicular. So let's go to that. So first thing is parallel. If you're going to be talking about lines that are parallel, it takes the same slope in order for lines to be parallel. It also has to have different y-intercepts. So as long as lines have the same slope and different y-intercepts, they're going to be parallel to each other. So they have to be on a different spot, otherwise they're going to be on top of one another and they're not going to be considered parallel. Then we're also going to talk about perpendicular. And I don't want to write it again, so there's symbols to these. So a parallel looks like that, kind of a double L, and perpendicular is an upside down T. So a perpendicular, in order for lines to be perpendicular, it's all about their slopes. So their slopes are opposite reciprocals. So if you know one slope, the opposite changes their sign, reciprocal flips your fractions. So we're going to take the exact same situation. We are looking for, so our first problem is we're looking for a parallel and perpendicular lines to y equals -3/2 x minus 5 that passes through -6, 1. So I'm going to do them exactly right next to each other, and you're going to see that it's really the exact same process. Literally the only difference is going to be the slope. So in order to make things parallel and perpendicular to this line, it's all about this slope. So I'm going to focus on that slope. So the original slope is -3/2. A parallel slope to that is going to be -3/2. So when we do the perpendicular, something that's perpendicular to it, this line would be going down, so our line has to go up. That's the opposite part. And then you also have to flip the fraction in order to really make it a 90-degree angle with each other. So we're going to be using 2/3. The process is going to be exactly the same. So our setup is still going to be y minus y1 equals m times x minus x1. And this is going to be y minus y1 equals m times x minus x1. Okay, so our coordinate is 6, 1. So we have y minus 1 equals parallel slope. And so we're going to take a -3/2 x minus our x value of -6. Over here, still going to be y minus 1 because they're both passing through the exact same point, except we're taking the perpendicular slope. So there's our perpendicular slope, and it's still going to be x minus x1, which is that. So exactly the same. Obviously now it starts to change because we're going to be distributing in a different fraction. But other than that, the work is exactly the same. So we'll distribute, finish this off real quick. And so we're going to get -3/2 x. Subtracting a negative is the same thing as adding. So we have a negative times a positive, and if we're going to take 3/2 of 6, we can do 6 divided by 2 is 3 times 3 is 9. y minus 1. We'll add 1, and that's going to get us our parallel. Negative 3/2 x minus 8. And then we'll finish up our perpendicular. So same thing, we'll distribute. We're going to have a 2/3 x. Positive times positive is a positive. 6 divided by 3 is 2. Times 2 is 4. Y minus 1. And then we will add our 1 over. So we're going to get y equal to 2/3 x plus 5. And to check it, it would be probably a good idea to graph them. I would graph this. I would graph this one, make sure it's parallel, make sure it passes through negative 6, 1. Graph this, it should be perpendicular to both of them actually, because if they're parallel to each other, it should be perpendicular. And but it should also pass through. So both of these two lines would actually cross each other at negative 6, 1. And that was writing equations of lines, parallels and perpendiculars, or just given two slopes or given a slope and a point. Thanks.